Let's see the next question. You need only one instance of a class across the application. How do you implement it? This is the singleton design pattern. The goal is to ensure a single shared instance and prevent multiple object creation. The standard approach uses a private constructor and a public static method that always returns the same instance. Thread safety is critical here. If two threads enter the instance creation method at the same time, multiple objects may be created. To prevent this, synchronization is applied. Now let's walk through the code. A class named appConfig is created. Inside this class there is a private static variable named instance. This variable holds the single appConfig object. The constructor appConfig is declared private, so no external class can create an object directly. Next, a public static synchronized method named getInstance is defined. Static allows access using the class name. Synchronize ensures that only one thread can execute this method at a time. Inside getInstance, a null check is performed. If instance is null, a new appConfig object is created and assigned to instance. If instance already exists, the same instance is returned. In the main method, getInstance is called twice and stored in cfg1 and cfg2. Then cfg1 double equals cfg2 is printed. If the output is true, both references point to the same object, confirming singleton behavior. This synchronized version is simple, safe, and perfectly acceptable for most interviews. For performance-critical systems, optimizations such as double-checked locking or static inner helper classes can be discussed if asked. Let's see the next question. Why does the get method in HashMap return null after modifying the key object? A HashMap stores entries using hashing. When an entry is inserted using put, HashMap calls the key's hashcode method to calculate a bucket index. After that, the entry is stored inside that bucket. Later, when get is called, HashMap again calls hashcode on the key provided. It uses that hashcode to find the bucket, and then it uses equals to find the exact matching key inside that bucket. Now here is the core issue. If the key object is mutable and fields used by hashcode or equals are changed after insertion, the hashcode changes. The entry is still sitting in the old bucket created using the old hashcode, but get searches in a different bucket based on the new hashcode. So get returns null even if the same key object is passed, because HashMap is looking in the wrong place. This is why HashMap keys should be immutable, or at least the fields used in hashcode and equals must never change while the key is inside the map. Now let's walk through the code. A class named employee key is created. It has one integer field named id. The constructor employee key takes an integer id and assigns it using this .id equals id. Next, hashcode is overridden to return id, and equals is overridden to compare id values. Now inside main, a map named map is created as new HashMap. Then a key object named key is created as new employee key with id1. Then map.put is called using key and the value developer. At this moment, HashMap calls key.hashcode, which returns 1 and stores the entry in a bucket for that hash. Then map.get is called using the same key reference. HashMap again computes hashcode as 1, finds the bucket and returns developer. After that, key.id is changed to 2. Now map.get is called again with the same key reference. But this time key.hashcode returns 2. So HashMap searches in the bucket for hash 2, but the entry is still stored in the bucket for hash 1. That is why the output becomes null. The correct interview conclusion is this. Never mutate a key once it is used in a HashMap. Prefer immutable keys such as string, integer, UUID, or custom immutable classes. Let's see the next question. Two threads modify an array list at the same time and data becomes inconsistent. Why does this happen? ArrayList is not thread safe. When multiple threads call list.add at the same time, the internal array and size counter can be updated in an interleaving way. This leads to race conditions. Race conditions can cause missing elements, incorrect final size, corrupted internal state, or runtime exceptions like array index out of bounds exception in extreme cases. Now let's walk through the code. A list named list is created as new array list of integer. Two threads are created named T1 and T2. Thread T1 runs a loop from I equals 0 to I less than 1000, and for each I it calls list.add of I. Thread T2 runs a loop from I equals 1000 to I less than 2000, and for each I it calls list.add of I. Then T1.start and T2.start are called, so both threads run at the same time. Then T1.join and T2.join are called, so main waits until both threads finish. Finally, list.size is printed. The expected size might look like 2000, but due to race conditions, the final size may be less, or the behavior may vary by run and machine. The correct interview solution is explained like this. If multiple threads must modify a list, use collections.synchronized list, or use a thread-safe collection like copy on write array list when reads are frequent and writes are rare. For high write scenarios, consider using proper locking or alternative concurrent data structures. Next question. There is a return statement inside try or catch. Does the finally block still execute? Yes, the finally block still executes even if there is a return statement inside try or catch. The important reason is that Java does not immediately exit the method the moment return is encountered. First, Java evaluates the return expression and stores the return value temporarily. Then Java executes the finally block. Only after finally finishes does the method return the stored value to the caller. This is why finally is commonly used for cleanup, such as closing streams, releasing locks, or restoring state. Now here is the interview trap that must be mentioned. If the finally block itself contains a return statement, then the return in finally overrides the return from try or catch. That is dangerous because it hides the original return value and makes debugging very confusing. Also, if finally throws an exception, that exception can override an exception thrown from try or catch. Now let's walk through the code. Consider that we have the final return demo class. Inside it, there is a static method named getValue that returns int. Inside getValue, there is a try block that says return 10. Then there is a finally block that prints the message finally block executed. Now in main, getValue is called and the result is stored in an int variable named result. When getValue runs, the try block prepares to return 10. Before the method exits, the finally block runs and prints finally block executed. After finally finishes, the method returns 10 and main prints returned value :10. In interviews, always add this line. If the finally block itself contains a return statement, it overrides the return from try or catch, which is bad practice. Next question. You catch an exception but do nothing inside the catch block. What problems does this cause? This is called swallowing an exception. Swallowing an exception means catching it and doing nothing, not logging, not rethrowing, and not handling it correctly. This is dangerous because it hides failures. The application may continue running with an incorrect state, partial updates, or missing data. In production, this leads to silent failures, wrong results, data corruption, inconsistent behavior, and very difficult debugging because there is no error signal. In interviews, a strong answer includes what should be done instead. At minimum, the exception should be logged with context. If it cannot be handled locally, it should be rethrown, or it should be wrapped into a meaningful custom exception and thrown upward with the original cause preserved. Now let's connect this to the code. A class named SwallowedExceptionDemo is created. Inside main, there is a try block where int result equals 10 divided by 0 is executed. That line throws arithmetic exception immediately because division by 0 is not valid. Control jumps to the catch block, which catches arithmetic exception with variable name e. But inside catch, nothing happens. So the program hides the failure and continues to the next line, which prints program continues execution. This output is misleading because a failure happened, but the program behaves like everything is fine. That is why swallowing exceptions is a real production bug pattern. In interviews, you should say this clearly. Always log the exception, rethrow it, or convert it into a meaningful custom exception. Never ignore it.